Equivalent ratios and rates and what are proportion. So let's go over our last lesson over how to graph ratio tables. So looking at this graph, what can you tell me? What can you tell me the pattern or interpret it? Describe the pattern in this graph. The x-axis is about number of CDs. The y-axis is about the cost of these CDs. So let's see, 1, 3. 1 CD, $3. 2 CDs, $6. 3 CDs, $9. It looks like, from what I can tell, for every CD, it will cost, for every CD, it will cost $3. That's what I can tell from this. So yeah, every CD costs $3. Another CD costs $3. Another CD costs $3. Or another way to say it's $3 per CD. So it costs $3 per CD. So, in our next one, imagine we're doing a cup stacking. We are going to be doing that in class where you stack the cups and then you have to break it down. So if someone did, let's say, 18 seconds. Let's do 16 seconds. It took 2 students to do 16 seconds to stack their cup. And it took 4 students 24 seconds. Express the relationship between the number of students and the seconds for each situation as a rate in fraction form. So let's start with the first one. We had took them 16 seconds for 2 students. In the other situation, it took them 24 seconds for 4 students to stack up the cups. Compare the unit rates. What do you notice? I need to find a unit rate. So I need to find how many seconds per student. What number is per? 1. 1 student. So 1 student, 1 student. And then let's make sure you label it. Very important that you label it. You do rates. So, how do you break down 2 students or scale down to 1 student? I divide both numbers by 2. 16 seconds divided by 2 is 8 seconds. So, when you have 2 students, the first 2 students who did it, it took up 8 seconds per student, which is actually not bad. That's pretty fast if you think about it. What about this side? If you take 4 students, how do you turn 4 students? Break it down to 1 student, divide by 4. So 24 seconds divided by 4 is 6. So, however, 4 students, for some reason, can do it at a faster rate or speed than 2 students, because they only took them 6 seconds per student. Are they equivalent? No, because this group of students is much slower than this one. It's 2 seconds slower per student than that group. However, what if we had another contest where there's 2 students took 8 seconds and 4 students took 16 seconds? Let's do a prediction. Will they be equivalent per student? Would a unit rate be equivalent? Let's see. Express the relationship between the number of students and the seconds for each situation as a rate in fraction form. So we have 8 seconds for 2 students. In this one, we had 16 seconds for 4 students. It's compared to unit rate, so we need to turn this to a unit rate for 1 per student, for 1 student. So how do you, and let's make sure you label your rates. So how do you break down or scale down from 2 students to 1 student? Divide by 2. Divide by 2. 4 seconds per student. That is really fast, much faster than the last example. How do you break down 4 students to 1 student? Divide by 4, divide by 4. 16 seconds divided by 4 is 4 seconds per student. Are they equivalent? Yes, because when you had 2 students, it took them 4 seconds per student. When you had 4 students, it took them 4 seconds per student. So they're equivalent. So these 2 ratios or 2 rates are equivalent. So when 2 ratios and 2 rates are equivalent, they're called equivalent ratios or equivalent rates. Equivalent again means equal, the same as. So there are different ways to determine if 2 rates are equivalent. One way is by determining unit rate, examining by examining unit rates. In our last example, we broke it down into unit rates, and then we compared the two numbers. If the rates have the same unit rate, they are equivalent. So let's look at these two examples. If someone gained 15 pounds in 5 weeks, ooh, that's not good. If someone gained 12 pounds in 3 weeks, also not that good. So we broke it down from, how do you break 5 weeks to 1 week? You divide by 5. So it's 3 pounds per week. However, in this one, how do you break down 3 weeks to 1 week, or 12 pounds to 4 pounds? You divide by 3. You break it down by dividing by 3. So are they equivalent? Did person 1 gain the same amount of weight as person 2? No, they are not equivalent, because this person, second person, gained an extra pound than the first person. Of course, it depends on it. If it's a sumo contest, then that's a good thing. All right, so use unit rates to determine if the pair of rates is equivalent. Explain your reasoning. Let's start with the first one. You have 49 flowers in 7 vases. 49 flowers, make sure you label it, in 7 vases. In another example, you have 54 flowers in 9 vases. Make sure you label it. But it said they would like us to use unit rate. So let's break it down to 1 vase per vase. How many flowers per vase? Per being divided into 1 unit. So let's take out a different pen color. How do you break down 7 vases, or scale down from 7 vases to 1 vase? Divide by 7, divide by 7. 7 vase flowers per vase. Pretty. What about this one? How do you break down 9 vases to 1 vase? Divide by 9, divide by 9. 54 flowers break down, divide by 9 is 6 flowers per vase. Are they equivalent? No, because there's 1 more flower per vase than this one. They are not equivalent. What about the next example? Maybe this one is equivalent. I don't know if it is. 13 t-shirts in 3 boxes. And you have 26 t-shirts in 6 boxes. So they said find the unit rate, so we need to break it down into 1 box. Make sure you label it. Very important you label these rates. So how do you break down 3 boxes to 1 box? You divide by 3. Divide by 3. What is 13 t-shirts divided by 3? So, let's add some zeros here. How many groups of 3 go in 13? 4 times. How many groups of 3 go into 10? 3 times. How many 3s go into 10? 3 times. You know what? I think it's repeating. So there are 4.33 repeating t-shirts per box. Of course, if you get around it, it's about 4 t-shirts per box. Because you really can't have 0.333 t-shirts. What about this one? How do you break down 6 boxes to 1 box? Divide by 6, divide by 6. 26 divided by 6. That adds some zeros here. How many 6s go into 26? 4 times. Bring down to 0. How many 6s go into, how many groups of 6s go into 20? 3 times. Hey, you know what? I think they are going to be equivalent. How many 6s go in 23 times? So it's 4.33, or also, if you get around it, about 4 t-shirts per box. So are they equivalent? Yes, they are. I'll be honest, I knew this was going to be it as a shortcut. Couldn't you have simplified 26 and 6 by dividing by 2, and you get 13 over 3? So I knew they were going to be equivalent. All right, now, so what is a proportion? A proportion is a statement showing the equality between 2 fractions. The fraction is usually ratio or rates. So these 2 would have formed a proportion. These 2 are a proportion because this rate is the same as this rate. They are equivalent. They are equal to each other. This rate and this rate are equivalent. Another one is if you put 13 t-shirts in 3 boxes, and you say it's the same as 26 t-shirts and 6 boxes. So, for example, you have 16 tomatoes and 8 peppers. It is equivalent to 4 tomatoes and 2 peppers. So, because you break it down by dividing by 4, or another way to say is you multiply by a fourth of it. 16 tomatoes and to 2 peppers is the same as 4 tomatoes to 2 peppers. So the scale factor is 1/4, or we broke it down by dividing by 4, scale down. So we are going to try different examples, see if these two are ratios or form a proportion. On our next lesson, we are going to find missing values of a proportion. So today we're just learning what is a proportion. So a proportion is when you have two ratios or rates that are equivalent. So you could buy 3 medium pizzas at the pizza place for $13 or 5 medium pieces. Wait. Oh, 3 medium pizzas for $13 or 5 medium pizzas for $30. Do these rates produce a proportion? Explain your reasoning. So, this is unit price. You might say, how did you know that? Because this rate involves money. Remember, to do unit price is cost per unit. How much does it cost for each unit, for each pizza? So in our first example, it costs $13 for 3 pizza. In our second example, it costs $30 for 5 pizza. So let's find the unit rate of each one. So if I'm going to find a unit rate of each one, then we'll see if they are equivalent. So 3 pizzas. I want to find it per pizza. Per pizza. So, can 3 pizza, how do you break it down or scale down to 1 pizza? Divide by 3. Divide by 3. 13 divided by 3 is 4. Add some zeros. Okay, I want to get rid of the remainder. How many 3's going to 10? 3 times. I think it's repeating again. So it costs $4.33 per pizza. Not bad. That's actually very cheap. Must be a very small personal sized pizza. What about this one? If I were to break down 5 pieces to 1 pizza, I divide by 5. I divide by 5. $30 divided by 5 is $6 per pizza. Do they form a proportion? Are these two rates or fractions form a quality? Are they equivalent? Are they equal to each other? No, they are not. Maybe our next example will have it. Determine if the race 5 laps swam in 8 minutes and 11 laps swam in 16 minutes produce a proportion. So explain your reasoning. So this is up to you the way you do it. And unit price is very important. It's cost per unit. But if this doesn't involve price, you could do 5 laps. You could do laps over minutes. Or you could do minutes over laps. It is up to you. It does not matter which one. But the labels are so important. You've got to have those labels. So you know what? I'll do minutes per laps. You can do laps per minute. It doesn't really matter one way or the other. I think in my notes I did laps per minute. So I'm going to do the other way around. So to give you a different way of doing it. So we have 8 minutes for 5 laps. In the next example, the next students did 16 minutes for 11 laps. Will these form a proportion? You know, before I even predict it, I think the answer is going to be no right now. Because if I build it up or scale up, 8 minutes times 2 is 16. 5 laps times 2 is 10 laps. So I don't think it will be. I think it will be a no. Because it should be, to make an equivalent fraction, it has to be 16 over 10. To rename 8 minutes and 5 laps, it needs to be 16 minutes and 10 laps. But you know what? That's my prediction. And I think it's a good prediction. But you know what? I would like to find it per lap. So I want to find a unit rate per 1 lap. Per 1 lap. So I need to find how many minutes per lap. So I divide both numbers by 5, divide both numbers by 5, because 5 laps divided by 5 is 1 lap. So what's 8 divided by 5? How many 8's going 5? 1 time. Bring down to 0. How many 5's going 36? So you can take some 1.6 minutes per lap. In the other example, if I want to break it down from 11 laps to 1 lap and divide by 11, so 16 divided by 11. How many 11's go 16? 1 time. 5 is the remainder. I bring that to 0. How many 11's go 50? 4 times. The remainder is 6. I bring that to 0. How many groups of 11 go to 65 times? You know, I'm going to stop right now. It's going to go repeat 1 and 45. It's repeating. But I already know I can stop right now because after I got 1 and 4 tenths, I know they're not equivalent. They don't have the same minutes per lap. So no, this is not equivalent. So my prediction was right. Because you know what? If you had renamed 8 minutes of 5 laps by building up by 2, by multiplying by 2, it would have been 16 minutes and 10 laps. So maybe our next example will be equivalent. Homeroom A has 25 students that collected 475 cans of food. Good for them. Homeroom B has 23 students that collected 437 cans of food. Do these collection rates form a proportion? Explain the reasoning. So it's up to you. Do you want to write the rates as students over cans? Or do you want to do cans over student? It really does not matter to me one way or the other. You want to find how many students per can? Actually, that's kind of weird. Or how many cans collected per student? I think cans per student sounds better. So we collected 475 cans for 25 students. In the other example, you collect 437 cans per how many students? 23 students. I would like to break it down to per student. I would like to find a unit rate per student. Make sure you label it. So, anybody want to make a prediction? Let's make a prediction. I don't really know. Let's see. You have 23 students collected 437. You add 2 more students that collected a little more. I don't know. Part of me say yes, part of me say no. I'm going to have to find a unit rate to figure this out. So I really can't tell you yes or no. If I had to say, I think it's going to be yes, but I don't know until I find a unit rate. So how do you break 25 students to 1 student divided by 25? So you have 475 divided by 25. How many groups of 25 go to 47? 1 time. What do you have left over? 22, bring down to 5. How many groups of 25 go to 225? 9 times. So you have 19 cans per student. That's pretty good. That's a very good food drive. Very generous children. 23 students, how do you break it down to 1 student? You divide by 23, divide by 23. What's 437 divided into groups of 23? You have 1. Ooh, so far it's the same. 0, that's 4 minus 2 is 2. I bring down to 7. How many groups of 23 going to 207? Well, you know, let's try 9 or 8. I'm going to try 9 for now. 27? Hey, it is. Groups of 9 groups of 23 go into 207. So they are equivalent. Or another way is that they do form a proportion. So 475 cans to 25 students is the same as 475 cans to 23 students. And that's the same as 19 cans per student. So again, so what did we really learn today? What we learned today is if you're given 2 rates, 2 ratios, or 2 fractions, can you tell me if they are equivalent? Break it down into unit rate or unit price. And then, if they are equivalent, it's called a proportion. Proportion is when 2 ratio or rates are equivalent. They form an equality. So next time, what we're going to learn is what happens if you had to, like for example, this one, what happens if you had to find this missing number right here? Or given why is this not erasing? Oh, given 5 cans, given 5 students, how many cans will 5 students collect? So we're going to find that next time.